Okay. Now make sure you see the announcement. Now remember, your test score will cover week 11 to week 13 only. So if you see the original revision note, okay, if you see the original revision note, it's from week 9 to week 13. Okay, I cut this short to week 11 to week 13 only. So no week 9, no week 10, meaning no coding. Clear? So the question also from 4, now it down to 3. So from 40 minutes, now it's down to 30 minutes. Clear?
So the test is for 30 minutes?
Yes, 3 questions.
Okay, I have a question. Will it be 1 page 10 minutes again?
1 page 30 minutes.
1 page 30 minutes?
Yes.
So
1 page.
I have full 30 minutes to do that, not like last time 10 minutes that we were.
1 page 30 minutes. 1 page 3 questions, 30 minutes.
1 page 3 questions?
Yes, 30 minutes. Now remember, the seat will be allocated before the test. Okay, so check your WhatsApp group and also on times. Okay, today we'll do our last lecture, which is week 13. Okay, graph. Now, for graph, we will not do graph traversal. Okay, so we only do minimum spanning tree, which I believe you have learned in your mathematics class. Okay. Remove. No graph traversal. Now, what we're interested in is this spanning tree. Now, remember, even though the name is tree, but it's actually a graph. Okay. So when you travel to the graph with special condition, for example, there's no cycle, then it becomes a spanning tree. Basically, spanning tree is when your nodes connected in some way or another. Okay. Now, why you're interested in this is because you can see, for example, you have this problem. Let's say these are the cities and these are the, let's say the distance. Okay. So if I want to visit all the cities, I can choose this path and I get the distance of 51. But if I change the path, now I get the distance of 41. So the question is there a way to get the minimum cost possible? Okay, that is minimum spanning tree. Now remember, the entire thing is a graph. The one in the blue is your minimum spanning tree. Okay, this one is minimum spanning tree cost. Now, if you're using two algorithms, one is critical, the other one is prim. Both are what we call greedy method. Greedy method is basically a normal method in computing. First come, first serve. Now, Kruskal is the easier one. So in Kruskal, all you need to do is just pick all the edges and then sort them out. That's it. Okay. So sort the edges from the smallest to the largest. For example, this one 0, 5 is this edge 0, 5, 10. Clear. So once you have sorted, then you just pick one by one. So first one is 10, which is this one. Then 12, which is this one, 12. Then 14, which is this one, 14. Then 16, 1, 2, 16. And then 3, 6, 18. 3, 6 is this. But notice that if I choose 3, 6, I'm creating a cycle. You cannot create a cycle. Clear? So I need to omit this 18. So I will not include 18. Clear? Okay. So we skip that. And then we continue with 22. 3, 4. This one. Because it forms a cycle like this. So you cannot form a cycle. If it becomes a cycle, you cannot choose. Okay. So 22, 3, 4, 3, 4, 22. And then 4, 6, 24. Now notice that if I choose 4, 6, now I'm creating a cycle. Okay. So same thing, I cannot choose this. This will create a cycle. So I will skip 4 and 6. Continue with 25, 4 and 5, 25. But notice that once I link this, I have basically touched all the nodes. Done. Okay. So your MST ends here. That's it. Because you have linked all the nodes. Okay. So you stop.
You don't need to make a cycle.
You mean down here? You cannot make any cycle.
You can make a closed cycle.
There is no closed cycle or open cycle. Cycle is cycle. Cycle means it's something like this. This is cycle. Okay. So it's a closed loop. That's cycle. So this is your MST, minimum spanning tree. Clear. Remember, this is not complete yet until you calculate the cost. So we call that MST cost. And your MST cost is 10 plus 12 plus 14 plus 16 plus 22 plus 25. So whatever value that you get, that is your MST cost. Clear? Any question? Any question? Okay. So Krusker is quite easy. You just choose you just list all the edges, sort them out, and then you choose one by one. If it's form a cycle, you skip. Okay. Clear? Okay, but Krusker is not very realistic. Okay. For example, if this is my city, so I have to start from 3. I cannot simply jump to other cities. Okay. So I need to start from here. So my journey will be either here to the left or to the right. So in Prim, you can choose where you want to start. Okay, so that's the difference. Okay. So it's more realistic actually in the real world. So Prims, but if there is no starting point specified, then you choose the lowest one. Okay. Now another thing about Prim is if in your Krusker you have this list and the list is fixed because you can have this list before you start. Okay. But in Prince, there is no such list. Before you start, your list is empty. There is nothing. Okay. Because your list contain edges or link that is currently connected to your minimum spanning tree. If I don't have the tree, then I don't have the list. Okay. So to build the first item, I will choose the lowest one, which is this one, 10. So 10, meaning it will include node 10 and node 5. Now my list will contain edges that connected to 0 and 5 only. Okay, meaning 28 and 25 only. This and this. So this is my live list, current list. Okay, only 2 items. So it will be sorted. So I will choose 25. Okay. So you can see, unlike your critical, I cannot jump to number 12, for example. Okay. Because number 12 is not connected to my current spanning tree. So once I've selected 25, which is this one, then this 25 will be taken out from the list. Okay. So I'm left with only 28. But once I'm connected to number 4, now I can include a new list, 24 and 22. So this is my updated list. Clear? Okay. So again, the list will be sorted. So you choose the smallest one, which is 22. This one. Okay. So 22 will be taken out. Now you're connected to 3. So I can include 18 and 12. So this is the updated one. 12, 18, 24, and 28. Okay. So choose the least one, which is 12. So now it's connected to this. So now I can include 16. So now the updated list includes 16. And because this is the list, so now 16 will be connected to this. So now I can include 14 because 24 is already inside the list. Okay. So this is the updated list, which include 14. Okay, then choose 14. And now I've connected to all the nodes. Done. So it stopped here. Clear. Any question? And but similar to the classical, if the one that you choose form a cycle, then you have to skip and then go to the next one. Clear? Any question? Remember, it's not over until you calculate the spanning tree cost. Okay. So the last step, sum everything to get the minimum spanning tree cost. Now the result of your prints might or might not be similar to your critical. Okay, it depends. Okay. Any question? Okay, can you do this? Critical. Find the MSD and find the MSD cost. You have 4 minutes. So what is the cost? How many? The cost? What do you get? What's the cost? What's the MSD cost? Huh? 21? Remember, you need to list out, okay, based on highest or smallest to largest. So the first one definitely will be number 1. And then after that, there are 2 trees, right? So I can choose both. And then this one. So now it's connected to this, connected to this, connected to this, connected to this, connected to this. So after that, 4. Then after that, 5. But there are 2 5, right? You can choose any one of these 2. So let's say if I choose this one, 5. So now it's connected to 3. Done. So all nodes connected. So what is my spanning tree cost? 5 plus 4 plus 3 plus 3 plus 1, which is 16, right? Clear? Any question? Your MSD tree will look something like this. Clear? Now, if you choose the other 5, you get the same cost. Your MSD will look something like this. Okay? Clear? Any questions so far? Any question? 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 Okay, do the exercise. Okay, this one. Okay, we have done number 1. Remember, your test question looks something like this. Okay, this is the type of the test question. You have done number 2, but only 3 questions. Now do number 4. So given this matrix diagram, create its original graph and link adjacency list undirected. So 2 diagrams. One is original graph. Remember, original graph is like this with arrows, and the other one is adjacency list undirected, which looks something like this. Clear? Graph will look something like this. Okay? You have 6 minutes. Right? You must choose 4 first. You must choose 4 first. Because remember, you must be sorted. So you have 1, then 3, then 4. Which is this one, right? But so this one, you have to choose 4 first. This is 4, right? So after 4, then you choose 5. But you cannot choose both. Only one. Either this or this one. So just one. Something like that. What do you mean by step by step? Oh, you mean, oh, it doesn't matter. This is spanning tree. Spanning tree is as long as it's connected to the node. It doesn't need to be one line or one path. As long as it doesn't form a cycle. Yeah, this is spanning tree. This one is not spanning tree because you have cycle. This is a graph, not spanning tree. This one is creating a graph, not spanning tree. Where's the arrow? It's digraph means directed graph. Directed means you must have arrows. Yes. So it must have arrows.
Then the other part, which is we done the template and get into the code. And then we talk about the monitoring code. Yeah. We are taking the monitoring. We do the same. We do the same. Then we give an setting and a code. Is that enough?
For sorting, you don't need to give any code.
Even selection and insertion.
Only for the searching.
We actually need to talk about this. What I did exactly, like, was explaining the solution as a normal and given a synthetic order. Then the insertion, explain each order to city. Then I give the code. Then I do a little bit.
You can do, but it is not required. Okay. For sorting, you only required to show how it works, demonstrate how it works, and then you get the BO and then you compare. That's it. You don't even need to show the code.
Yeah, that's exactly like we would explain this, even accept solution swap, then the insertion swap, then you give me the comparison.
The comparison is the comparison between the BO. The complexity, the BO. Yeah. Volunteer. Original graph. Original graph. Draw. Original graph. Original graph. Volunteer. 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 Original graph. Original graph. Original graph. Volunteer. Original graph. Original graph. Volunteer. Original graph. Anybody man enough to volunteer? Volunteer. Volunteer. Original graph. Original graph. This one. So you just not 1, 2, 3, 4, 5, 6 or 1, 2, 3, 4, 5, 6 and then link them. Six. You can just put anyway. Doesn't matter. You can see here. If 2 link to 1, right? It means 2 point to 1. This one. Diagram. Okay. Like that. Number 14. Number 4, 3, and 5. Number 4. Okay. Done. So this is the graph. Now remember, you can tabulate the nodes in any way that you want. You can do 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. It doesn't matter. Okay. It doesn't matter whether the line crisscross or you have to do like this. Doesn't matter. Clear? So remember, this is directed graph. So meaning, whatever you see on this left side will point whatever you see on the top side. Okay. So if you see 1, it means this is pointing to that. Okay. So 1, nothing. So nothing. 2 points to 1, 4, and 5. So 2 points to 1, 4, and 5. 3 points to 1, only 3 points to 1. 4 points to 3 and 5. 4 points to 3 and 5. 5 points to 6. 5 points to 6. 6 points to nothing. Clear? Any question? Any question? Okay, next, do adjacency list undirected. So you can get that from here. So it should look something like this. Okay, so something like this. Okay, you have 1 minute. Any volunteer? Adjacency list undirected. Any volunteer? remember this is undirected. Okay, undirected means if this is connected, it's considered inside the list. Number 1, right? Connected to 3 and 2. So 3 and 2 will be inside number 1 list because it's undirected. This one is directed. Clear? Correct. So if you see connection, then you include. Okay. Okay, so remember this is undirected. Okay, undirected. Now, first you need to show that the left side is an array. Okay, so either you do something like this or you can do something like this. Okay, up to you. So you must show that it's an array. Okay. On the right side, you must show that it's a linked list. So you must link the list, and at the end, you show that there's a null value. Or you point to null, up to you. You can do like this or you can do like this. As long as there is an indicator telling that that is a null. Clear? Okay. So in this case, because it's undirected, if you see the connection, then it becomes the member list. Okay. So 1 connected to 2 and 3. So you see 2 and 3 here. 2 connected to 1, 5 and 4. 1, 4 and 5. Now, whether you put 1 for 5 or 5 for 1, it doesn't matter. Clear? The order doesn't matter. Okay. Then 3 connected to 1 and 4. 4 connected to 2, 3 and 5. 5 connected to 2, 4 and 6. And 6 connected to 5 only. Clear? Any question? Any question? 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 Okay, you can take your short break, come back at 5:05.
this
Right? Oh, you mean this color? 2-4 or 4-2 doesn't matter, right? Doesn't matter.
Okay.
You can put 2-4 or 4-2.
Just need to know the 2 and 4 is beside the 1 is okay. So the term is not.
Order doesn't matter because 1 linked to 2 and 4, right? So you can put 2, 4 or 4-2, doesn't matter.
Yeah.
Okay. This one, you must put the children, otherwise you cannot see. Okay, you cannot see why this one is not there. Okay. So if you see this, okay, if you look on the A, right? And the A, you will see this. You'll be like this. So one of these will link to only one of them. It's not A, this is B, right? So this is for A. This one is for C. You see? Okay. Because this means greater than B but lesser than. It cannot be D. Some of the number like D, lesser than D. Okay. So K here, this means bigger than D but smaller than K. So this one is here. This one is bigger than K. Clear? So you must do this. E coming from here, the K, because E is bigger than D, smaller than K. This one is for bigger than D, smaller than K. Clear? Okay, let's continue. Okay, next do this question 6. Now this one you should be able to do this very fast, very quickly. Okay, question 6. You have 2 minutes. Okay, done? Okay, done? So provide any path to show a cycle. 6, 8, 2. Now remember, if you put 6, 8, 2, you will get 0. Okay? It must start and ends at the same place. That is a cycle. Okay? Or you can put 8, 2, 6, 8 or 2, 6, 8, 2. Same thing. Okay? Okay, calculate a degree in at node 2. Degree in means arrow going in. Okay, at 2, 1, 2, 3. Calculate D plus G8. D plus means arrows going out at 8, 1. Degree out at node 4, 1, 2. D minus G1, degree in at 1, 0. Clear? Any question? Any question? This one? D plus means degree up. Degree out means arrow going up. Arrow going up. Okay. Question? Any question? Question? Okay, now do this. So this one is given adjacency list. Okay, diagram. Create its original diagram. And link adjacency matrix undirected, meaning this type of diagram. Okay. Okay, you have 6 minutes. Original graph done? Any volunteer? Original graph? Original graph? Any volunteer? Volunteer, original graph? Volunteer for your country. For your country. For your country. Original graph. Original graph. Okay, only this one. Okay, so similar to your adjacency matrix, if you don't see any members, meaning there is no arrows pointing to that. So 1 has nothing pointing to, and then 2 has 1 and 4. So 2 is pointing to 1 and 4. So 2 is pointing to 1 and 4. 3 points to 2, 3 points to 2, 4 points to 3, 5, and 6. So 4 points to 3, 5, and 6. And then 5 points to 6. 5 points to 6. Any question? Any questions? Adjacency matrix undirected. Volunteer. Agency matrix undirected. Volunteer. 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 Agency matrix undirected. Volunteer. 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 Better follow this. Remember, this is undirected. So anything connected, consider as one. It's okay. It's okay. Okay. Now remember, this is undirected. Okay. So anything connected to this number will be not will be notated as 1. Okay. So 1 connected to 2, 2 connected to 3, 4, and 1. So 2 connected to 3, 4, and 1. 3 connected to 2 and 4, 3 connected to 2 and 4, and so on. Clear? And because this is undirected, so I can check the mirror image, okay, whether they are symmetrical or not. So this one, this, so they are mirror image. Clear? Any question? Any question? 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 Okay, next one. Okay, this one. But instead of curl, I want you to do prims. So give me MST and MST cost. You have 4 minutes. Okay, done. So what did you get? What's the cost? What's the cost? 40. Okay, remember this is sprints, so you need to know where to start. In the absence of the starting point, so I will start with the smallest one, okay, which is this one. Clear? So the next number must come from this, or this one. Okay. So clearly 5 is the smallest. So which is 5. So now I can include 7, 11. Now the next number is 6. But if I include 6, I will create a cycle. So 6 will be excluded. So the next number will be 7. So now I can include 10 and 4. So the next number will be number 4. Now I can include number 8. So next number will be 8. So now I can include 15. Okay. Now next number is supposed to be 9. But if I choose 9, I will create a cycle. So 9 will be excluded. Then number 10. 10 also will create a cycle. So 10 will be excluded. 11 will create a cycle as well. So 11 will be excluded. So now my choice is either 14 or 15. And 14 is smaller. So I will choose 14. Done. All connected. So your MST is supposed to be something like this. Okay. Clear. So the cost, you need to add 14 plus 2 plus 5 plus 7 plus 4 plus 8. $40. Clear? Any question? Any question? 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 So remember your test. Okay, so you answer on the question paper itself. So there are 3 questions. So answer all on the test paper. The question will be posted on the big screen. Okay. So you just answer here. Any question? Any question? 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 And remember, next tutorial will be your final exam revision. Okay, next week tutorial. One more thing. %43.1% responded. If you have not done this, do this. Okay. Until 50% responded, this will remain red. I will get every hour reminder. Okay. You can go to final exam tip as well. Okay. Follow the tip, you will get A. Confirm. Just follow the tip. Okay, you will get A. Okay, your attendance. Now, once you get in attendance, you can leave. Okay, but if you have any question you want to ask, you can stay. You can ask me. Okay. You can just come. The attendance, you will not counted anymore in the final video. So no problem, you can just come. And later you can just message me telling that you have come for the morning class. So you need attendance to be corrected. Okay. For the final, in fact, costly. Oh, this one. If you see this one, it means it's a code. See this one, code. This one, code. So the code is already specified. Code. Next is this one. This one. That's the revision for this one. Code is here, but remember, now I said this will not be included. So only this. So there is no coding. No code. Attendance. Attendance.
Only lecture.
11, 12, 15. Attendance done, attendance. This is for first segment.
Yeah, some first segment.
Oh, the first part or which one?
First part.
Okay.
So I just show the formula of this in every question. And for J.
So where is the expression?
Expression. Huh? Sorry.
Find this one.
Yeah.
So where is the expression that you get, the complex expression? Okay. Remember from this, you cannot get the big O. From this, it's the same like the top one. You need to get the dominant term and then so it's the same justification as the previous one. Yeah. It's just a code.
Just like code.
Undirected. This one is already, this one. This is directed. Okay. This one is directed. From directed, I can build undirected. So from undirected, you cannot build directed because undirected is not error. But from directed, you can always do both directed and undirected. So this is undirected. This is directed. So from this directed, I can create undirected. Yes. Evaluation.
Yeah, the TES.
Which one?
The TES. Is it anonymous?
It's anonymous. Why you worry? It's anonymous.